So today I'm going to look at a linear differential equation with constant coefficients. We're going to use the annihilator method to annihilate whatever functions on the right hand side of my linear differential equation with constant coefficient. We got to use some operator notation. Big D is going to be d dx, d squared, then it's d squared dx squared, and d cubed is d cubed dx cubed. And eventually dn is going to be dn, little dn, divided by dx to the n. So what is the equation I want to solve? It's going to be y double prime minus 2y prime plus y is equal to x cubed plus 4x. Immediately the complementary solution is going to be y sub c is equal to c1 e to the x plus c2x e to the x. Because when I factor the auxiliary equation, namely m squared minus 2m plus 1 equal to 0, that's really m minus 1 squared equal to 0, so hence I get my complementary solution. So I use my operator notation. So my original equation come out to be d squared minus 2d plus 1y equal to x cubed plus 4x. Now how do I annihilate x cubed plus 4x? I just need a fourth order derivative. So I multiply both sides by that fourth order differential operator, and I get 0 on the right hand side. I have annihilated my right hand side, hence the annihilator method. But in so doing, I come up with another solution that should exist for my differential equation. Since I got order 6 on that operator big D, I should have y is equal to c1 e to the x plus c2x e to the x plus c3 plus c4x plus c5 x squared plus c to 6x cubed. So now I know what my particular solution should be, separated from the complementary solution part that we had. It should be, let's just rewrite it now as a plus bx plus cx squared plus dx cubed. Now I go back to my original differential equation. I'm going to need a y sub p prime and a y sub p double prime. So y sub p is what I stated it was conceptually. Then my yp prime is just b plus 2cx plus 3dx squared. And my y sub p double prime has to be 2c plus 6dx. So now I got the differential equation y sub p double prime minus 2 y sub p prime plus y sub p is equal to x cubed plus 4x. Doing my substitution using my y sub p, my y sub p prime, and my y sub p double prime, I come out with d equal to 1, c equal to 6, b equal to 22, a equal to 32. So my y sub p then is x cubed plus 6x squared plus 22x plus 32. That means my general solution then is y is going to be c sub 1 e to the x plus c sub 2 x e to the x plus x cubed plus 6x squared plus 22x plus 32. Once again, I used the annihilator method, where I found the operator would annihilate what's on the right hand side. Had it been e to the 3x, I would have used d minus 3, depending upon what function you got on the right hand side, what differential operator you need to manufacture to annihilate it. That's why we call it the annihilator method. We come up with a proposed solution that's got coefficients in it. We find a particular part of it, as we did. Then we have to go back and plug it into the original equation, which we did do, to find the constants for it. And then we get our general solution by adding it to the complementary solution. And there we have it, folks. Isn't this a beautiful thing? I hope you enjoyed the lecture.